molecules and other water molecules to water molecules, or pwede din sodium chloride with in water. So, two or more molecules. So, yung forces of attraction na pwedeng ma-observe dyan, we call it intermolecular forces of attraction. In organic compounds, among organic compounds, yung first three on the list ang common among organic compounds. Yung last listed sa table, yung ion dipole, common naman yan sa mga inorganic compounds. The session. You can also eat while listening to the review lecture. Okay, let's recall on increasing strength of attraction. Wherein yung very strong attraction dito is observed between ion dipole na type of IMF or intermolecular force. Then yung weaker strength naman is being observed sa London dispersion na kind of molecular force of attraction. And this is commonly observed again sa mga non-polar molecules. Yung dipole-dipole at saka hydrogen bond, observed yan sila sa mga molecules na may polar bonds. Specific nga lang yung hydrogen bond. So yung hydrogen bond, this is commonly observed kapag may nabuong bonding between hydrogen atom towards oxygen or attraction between hydrogen towards nitrogen or fluorine. Basta bonded si hydrogen or attracted ngayon yung hydrogen ng isang molecule to a highly electronegative atom ng another molecule. And specific lang yung mga highly electronegative atom na pwedeng mag-cause ng attraction to hydrogen, forming hydrogen bond. So it could be oxygen, nitrogen, or fluorine. Okay, then kindly take note of this. Biochemistry, ito siya na concept or kumbaga information related to hydrogen bond. Yung nasa last column ba on hydrogen bond, ma-mention na siya ninyo sa pag-review ninyo on biochem, sa proteins and DNA. Again, has a secondary structure ng protein na ay observable hydrogen bond already. And then sa DNA naman, ma-observe hydrogen bond between complementary bases. So yeah, this time, let's have let's try to review what is then the influence of intermolecular forces of attraction. Ano ba yung kaya niyang i-affect na properties? On the list or on the handouts provided, nakasulat dyan ng mga properties that could be affected by IMF is 1, polarity. Also, may relationship yan agad, diba? Pag it could affect polarity, it could also affect solubility of that molecule towards water. Pag polarity, kasi diba si water always described siya as highly polar. Okay? Therefore, kung talking about how IMF influences polarity and connecting that to solubility, we could say nga directly proportional. Kumbaga, the higher or the stronger the intermolecular forces of attraction observed, more likely higher din yung solubility niya towards water. Kaya diba based ani nga table sa strength, kapag increase yung polarity ngayon, kasi if you go down, increasing diba yung strength, and based sa strength or based sa order, pababa, nag-i-increase yung polarity property. Okay? Ito, polar. Polar, lalo na yung may metal bonded to a non-metal. Okay? So, kumbaga, pag sinabi natin greater ngayon yung strength ng intermolecular forces of attraction, that also tells us na greater yung dipole moment. Kaya may nakasulat dyan, di ba? The larger the dipole, stronger din yung intermolecular force of attraction. Okay, so kung stronger yung dipole, yung polarity ngayon, greatest polarity yung observed, greater din yung solubility niya to water kasi water is highly polar, like dissolves like man, di ba? Ang ato ang concept kapag solubility. So kindly take note, how does IMF influences polarity and also solubility? Directly proportional. Solubility, ayan. Directly proportional ha. So, ang yung order na binigay dito, therefore, among organic molecules, di ba, ito yung mga ma-observe na IMF, hydrogen bonds, dipole-dipole, at saka van der Waals. So, based sa order, greater ang polarity man ang observed sa hydrogen bond, then it is the one that is greatly or more likely dali ma-dissolve sa water. Followed by dipole-dipole, then least likely soluble sa water yung van der Waals. Kasi if you recall, saan ba usually makikita ang van der Waals forces of attraction, mga hydrocarbons? Sige, you tell me, kapag hydrocarbons ba, polar or non-polar? Generally speaking, you can, okay, very good. Diba, pag hydrocarbons, kapag lipids, oils, yan, non-polar. So kung imo siya i-relate sa solubility niya to water, it doesn't follow this principle on solubility. Always gina like dissolves like solubility. I hope you understand no this order. Okay? So dumdumi na siya. The stronger the IMF, greater yung polarity. Therefore, more likely, easily sila ma-dissolve in water. So directly proportional. Yung IMF towards strength ng IMF to polarity to solubility. Now, how does IMF naman influences melting point and boiling point? Now, there are two factors that could influences melting point and boiling point here. So, number one, yung strength ng intermolecular forces observed. Sabi dito, stronger IMF means higher din yung melting point and boiling point characteristic ng molecule. Kasi it tells us na kung stronger ang IMF, okay, then sabi dito, stronger daw, or not stronger, higher daw yung melting point at saka yung boiling point characteristic. Bakit ba needed, or kumbaga bakit pa higher melting point, higher boiling point ang needed? Kasi sabi dito, kung stronger ngayon yung intermolecular forces of attraction, we need higher energy din to separate molecules, to melt no that molecule, to break bonds no dyan sa molecule. Syempre kapag sinabing melting point, boiling point, we are sort of breaking, di ba, bonds here, chemical bonding here. So kung very strong ang IMF, ang force of attraction, intermolecular force of attraction, we need more energy to separate molecules. Kaya higher melting point, higher boiling point ang required. Okay? Then dito naman, another factor nga pwede palang makapag-influence sa melting point and boiling point ng molecules is the number of carbon in an organic molecule. Kasi we're talking here organic compounds man. So number of carbons could also in fact influence melting and boiling point. Sabi dito, the larger the compound or the longer the compound, higher ang melting point at saka boiling point needed. Okay? So kindly take note also of this factor. So isipin nyo, kapag higher yung hydrocarbon content in that molecule, mataas yung chance na higher din yung melting point at saka boiling point niya. Now, on the given example here, okay, yung tatlo, yung first three, puro hydrocarbon man yan. And they all have the same number of carbon. Tama? Pareha sila tanan o nga naa sila 5 carbons. So we cannot compare sino dyan yung mas maraming carbon kay equal man gyud sila og number of carbon. So how do we know no na sino dyan yung may higher or lower boiling point or melting point? Kindly take note as well na in relation to the number of carbons, the branching could also affect the boiling point. Kindly take note ha nga ang branching could lower the boiling point of an organic molecule because it reduces the surface area na kung saan pwede doon sana mag-cause ng or mag-form ng forces of attraction. Okay, so it reduces, pakisulat na lang, it reduces the surface area, okay, where the forces may interact. Okay, so that's the reason bakit branching may lower the boiling point. Kaya kung i-compare yung tatlo, ang more branches would be ito, 2,2-dimethyl propane. Kaya, tingnan niyo yung nangyari sa value or boiling point ng ethane. As the boiling point, it reduces the surface area where the forces may interact. Okay, so kindly take note of those factors nga pwedeng magka-influence sa melting point, boiling point. One is the strength of IMF, number of carbons, and the branching as well. Now, let's have this table. Now, sa preceding slides na ay mga table. Ito, may kinalaman ito sa una na factor, yung polarity, at saka yung solubility. Na tingnan yung sa table. These are all ethers. Di ba ang ethers na functional group is ROR. That's the type formula of, ethers. Now, try to compare the solubility of a smaller ether. Pag sinabing smaller ether, it has lower number of carbon. Okay? Versus that of larger nga ether. Meaning, meron siyang larger R group. No? Larger yung R group. Yung mas soluble between these set of ethers are the smaller no nga ethers. Bakit as we increase the carbon here, yung solubility niya lesser ngayon or insoluble na talaga? You go back to this kumbaga influence of IMF on polarity. Diba? Kapag sinabi nating greater na ngayon yung R group, larger na ngayon yung R group tells us na these are non-polar portion ng ether. Tama? Yung mga underline dyan, those are non-polar kasi hydrocarbons yan. Basta hydrocarbons, non-polar yun nga portion. And we're talking about here solubility niya sa water. Characteristic ni water again is highly polar. So it makes sense nga kung marami na yung non-polar portion in that ether molecule, then least likely na siya soluble in water. Okay, are you following? Can you show a thumbs up if you follow? Okay. Sige. Kumpara sa smaller nga ether. Kung smaller ether, it can still be dissolved in water kasi somehow mas malaki pa yung polar oxygen kumpara sa kanyang R group. Okay? And a polar oxygen tells us na siya greater polar characteristic yung buong molecule. Pero kapag dumami na yung hydrocarbon portion niya sa gilid ng ether, then least likely na siya soluble in water. Okay? Then on the other table naman, ito naman is an example of a set ng hydrocarbons din. Mga hydrocarbons nito. no? Particularly straight chain alkanes yan. Mula methane hanggang hexane, methane hanggang hexane. So ito naman na set of example is to show how intermolecular force influences melting point at saka boiling point. Sige, balikan natin kanina yung concept. Sabi natin, as the number of carbon increases, higher melting point, higher boiling point ang needed. Okay? So tingnan, as we go down the table, ayan, increasing 'di ba ngayon yung number of carbon. Tingnan yung values ng boiling point, melting point ni hexane versus that of methane. Siyempre, higher boiling point for those hydrocarbons nga rich in carbon atoms. Higher melting point than yung sa rich in carbon atoms na mga hydrocarbon. Okay? I know you are familiar na no, kapag negative nga value, di ba? It tells us nga yung kung negative value, kung closer to zero siya, it means higher value. Tama, di ba? Okay, negative man. Okay? Sige. So, higher ni siya na melting point kumpara sa taas. Okay? Sige. So, just notice kani siya. Kaning nga mga factor yung relationship, kung directly proportional, and how does it affect IMF. Para kahit anong question related to that, you could answer. Okay, sige. So we're done with intermolecular forces of attraction. This time, let's move on to another concept on organic chemistry. Ito din very high yield, essential to be reviewed. Okay. We have this concept on resonance. So I know you're familiar with resonance. And siguro you have also encountered this strain sa medicinal organic chemistry. So i-review din natin siya dito. Let's start with strains. Kapag sinabing strains, atong i-change ang color ha sa font. Ayan. So, ang strain, it tells us na, or it refers to instability of a molecule, instability of molecules, or instability in molecules. Okay? Yan. Pag sinabing strains, strain effect, yun yung mga effect that causes instability to a particular molecule. So pwedeng ang instability could be caused by changes sa bond angles na dapat, kasi 'di ba pag may formation of or arrangement ng mga atoms in a molecule, naragid na sila specific nga kumbaga arrangement, molecular geometry na pina-follow kasi in order na ma-minimize yung repulsion na nangyayari kapag nagkalapit yung mga surrounding atoms, okay, in a molecule. Yun yung VSEPR theory, di ba? Yung valence shell, electron pair, repulsion theory. Yan yung rason bakit we have different molecular geometry. Okay? Pero kahit nga gaano pa tayo ka specific on having such molecular geometry being observed sa mga molecule, there is always pa rin, no, or usually, not always, but usually na aghihapon tayo ma-observe na mga instability in molecules. Okay? So, isa doon sa mga strain or instability na kukos is deviation sa bond angles. Yun yung ring strain. Meron din tayong tinatawag na steric effect. Meron ding torsional strain. Sige, let's try to identify them, define them based on the given na information dito. Unahin natin yung ring strain. Ang ring strain, sabi dyan, twisting of angles away from expected due to ring closure. So obviously, this is observed among cyclic ring molecules, ring molecules. So this happens kung ang bond angles, they are forced away from the ideal. Okay, ideal nga values. Dahilan is nagkaroon ng closure ng ring. O magbigay tayo ng example. Halimbawa, talking about, if you try to compare, di ba, an open chain nga propane versus that of a cyclic propane. Unahin muna natin yung propane. Di ba ang propane is CH3, CH2, CH3. If you try to draw, it's 3D. 3D nga representation. Pwede natin isulat this way. Lahat in sp3, lahat ng carbon in sp3 nga hybridized lahat ng carbon in sp3. Kasi nga, singly bonded lahat ng surrounding bonds in a carbon. So that represents, halimbawa, propane. Open chain siya. Pero kapag nagkataon na this structure, nagkaroon ng closure ng structure na to forming a ring structure. Di ba yung ring equivalent, we call it cyclic propane. So kung ato siyang i-draw, sige, ato na lang ipakita ang iyahang mga central carbon. Sige. Well, yan. So, one carbon, atong i-close ang structure in a form of a ring. So, ayan. Dayon, okay. Sige. Okay. So, ayan. So, kung, because of the, ayan, yung mga sinulat ko na mga surrounding bonds, following ano lang net, molecular geometry, na dapat kung sp3 hybridized, di ba dapat iyahang arrangement or molecular geometry is tetrahedral. So isipin nyo, lahat ng carbon dyan naka-tetrahedral shape. Okay? So from an open chain nga propane, okay, because of the closure ng ring, we could expect nga hindi na yung ideal values of bond angles ang ma-observe dito kasi nag-close na yung ring, mataas yung chance na there will be changes also. Changes or twisting also ng mga angles. No? Nga different from the expected. Ano ba yung dapat expected kung sp3 hybridized? Pila ganito ang ideal bond angle kung naka-tetrahedral? I know you have reviewed already. Siguro, yes. Sige, very good. Yeah, four bonds. Ano yung bond angle? Ideal bond angle kapag tetrahedral. The bond angle. Okay, very good. Naka 109.5 degrees bond angle. Ngayon, nag-close man yung ring. Kung nag-close ang ring, syempre, mataas yung chance na magdidikit-dikit, no, yung mga atoms kasi nag-close nga yung ring, lalo na small ring ito. It's a small ring kasi it consists of the minimum number of atoms to close a ring. Kasi syempre, ang minimum number ng carbon to close a ring is 3. Okay? So from 109.5 degrees, pwede yang ma-alter. Okay? Ma-change, ma-twist yung angle na different na ngayon from the ideal band angle. Hindi na yan siya actually 109.5 degrees dito kapag nag-close yung ring. Okay? Probably pwedeng lumiit. Let's say 60 degrees o 60 to 75 degrees. Basta ma-change, no? Because of the twisting, the closure of the ring. Yan yung ring strain. So, observable siya sa mga smaller ring structure. Okay? So, yan yung ring strain. Kailan naman observable yung torsional strain? Okay, base sa definition, closing of angles between parallel bonds, drawing atoms closer. So ang nangyari dito, it happens when atoms this time are forced to be closer than the preferred nga distance. So ang nahitabo, halimbawa, magbigay tayo ng example para easier understanding. Let's say yung ethane. 'Di ba? Ang ethane is CH3, CH3. So that's ethane. Now, we have different ways how to represent 3D arrangement of atoms in a molecule. Diba? We have what we call the, halimbawa, Newman projection. Halimbawa, i-present na to ang 3D. 3D arrangement ng mga atoms in an ethane using Newman projection. I know na you have heard about this, Newman projection. So, ganito po yung presentation niya. Pwedeng in two ways. So, itong dot sa gitna, yung nasa harap na carbon, and then yung bilog sa likod is the carbon, okay, next na nasa front. Okay? Ayan. So, hydrogen, hydrogen. Okay? So, that's this formation actually, conformation, kumbaga, ng ethane using Newman projection is naka-eclipsed. Ito yung naka-eclipse, di ba, na conformation. So, tingnan nyo, yung from this carbon, no, di ba, meron siyang hydrogen sa harap din. O, tingnan nyo yung mga atoms din na nasa likod na carbon. Yung circle naman na nasa labas, isipin nyo, yan yung carbon na kasunod. Kasi dalawa yung carbon, di ba, sa ethane. So, mayroon din siyang surrounding hydrogen. And look at the hydrogens from the surrounding. From the fronting carbon and yung nasa likod na carbon, parallel sila. Naka-align sila. It tells us nga atoms are drawn closer. Okay? They are drawn closer. Kaya dito, kung ganitong klaseng conformation ng molecule of ethane, naka-eclipse, we could observe torsional strain talaga because of the parallel closing of angles between parallel bonds, aligning of atoms. Kaya meron tayong best nga, di ba, best conformation for ethane using Newman projection. Yun yung staggered. So kung staggered, the more stable. So ako isa i-draw ha. So ito yung nasa harap na carbon with surrounding hydrogen. And then yung, ayan, yung nasa likod this time na carbon, staggered na ngayon yung surrounding hydrogen niya. So yan yung more stable. Okay, more stable conformation. So in that way, we cannot observe torsional strain. Dito, usually kapag eclipsed, isulat nyo, take note, kapag naka-eclipse yung conformation, may torsional strain being observed because of the alignment, okay, ng bonds. And then lastly, kapag steric effect naman, this involves bulky groups. Wherein, because of the presence of bulky groups, nagko-compete sila ngayon sa space. And they tend to push bonds away from the expected angle. So let's have an example. Pinaka-common example dito for steric effect is yung halimbawa, let's draw the, okay, yung conformation ng cyclohexane. We have different conformation ng cyclohexane. Yung pinaka-stable nga, di ba, is yung chair conformation. Okay, substituted particularly na cyclohexane. So, unahin natin yung conformation na boat conformation. So, it looks really like a boat. Ayan. Then, let's say, merong, lagyan natin ng substituents. Okay? Ay, sorry. Ayan. Asa na yun? Okay. So, lagyan natin siya ng CH3 dito halimbawa. Then, dito din, CH3. Okay. So, this example of a substituted na cyclohexane, for this portion, o-observe talaga tayo ng bulky groups. These are examples of bulky groups. And because of the presence of bulky groups, may steric effect ngayon. Pwedeng mag-compete ng spaces dyan, no? Causing repulsion yung mga bulky groups. Kaya mayroon tayong stable nga. Mas stable, more stable, conformation for cyclohexane, yun na nga yung chair. Okay, so kung chair naman, looks like this. Okay. Okay? So, parang ganun. Yung structure niya. Ayan. So, kumbaga, kung imo siyang i-draw, nandito na yung CH2, isa. Nasa kabila naman yung isa. Diba? So, mas less likely mag-cause yan ng steric effect. Okay, ito yung chair conformation. Ito naman yung boat conformation. Between the two, again ha, more stable conformation for kumbaga, cyclohexane na structure is yung chair para maiwasan yung steric effect. More stable ito kasi mas naiiwasan nyo yung steric effect. Okay? So yung point natin dito sa kumbaga observable strains, kapag sinabing strains observed in an organic structure, it tells us na nagkukause sila ng instability on molecules. Okay? It causes instability sa molecules. So there are tendency nga ang electrons in different bonds, of course, since they tend to repel each other, okay, they are expected to form a particular molecular geometry. And yung strains, they are said to be the forces in an organic compound that tend to cause instability, that causes to destabilize the structure. Okay? So yan yung point natin kapag strain. Now, on the other hand, meron din naman tayong cases, there are cases wherein electrons this time could cooperate and maintains the stability. Kung kanina ang strains nagkukos ng instability sa molecule, okay? Pag resonance naman, okay, when you heard about the concept resonance, electrons here cooperate. Electrons move around adjacent atoms to maintain stability of the molecule. Okay, so yan naman yung resonance. And this could be observed, no? Sa inorganic compound, pwede din naman sa organic compounds. Okay? Ang resonance na halimbawa binigay dito is yung kay carbonate. Okay? And by the way, kapag sinabi nating resonance, since paano ba siya nagme-maintain ng kumbaga stability or stability sa molecule? It is because of electron delocalization na nangyayari across the molecule. Kumbaga, distributed among adjacent atom yung electrons. Okay, yun yung electron delocalization. So, i-describe natin ha. Resonance describes the delocalization, okay, of electrons across molecule. Commonly observed ni siya among structure na conjugated nga system. Pag sinabing conjugated system, there is an alternating single bond, double bond, single bond, double bond. Diha na to ma-observe ang resonance. Okay? Now, before I continue, may I please excuse myself for a minute lang. I will take a personal necessity. Thank you. All right, let's review. So the given example here under resonance is an inorganic compound of carbonate. Okay, so that represents an ion. It's CO3, di ba? -2. So, ayan. So kung you try to observe the given, kumbaga, Lewis structure of carbonate showing resonance, it tells us or it shows na there is a double bond next to a single bond. Okay, so that is where we could observe resonance. If we see a molecule with a double bond next to a single bond, then another double bond next to a single bond, mataas yung chance na may resonance, electron delocalization across molecule on that given sample. With regards to the Lewis structure, try nyo din i-review ha, yung, kumbaga, yung approach, yung, kumbaga, the steps on how to write Lewis structure, just the basics. Diba kung atong i-recall, paano ba natin i-write ito? Paano ba nag-come up ng ganitong Lewis structure forming resonance ng carbonate? Okay, carbonate or any molecule, paano magsulat ng kanyang Lewis structure? First things first is you you have to know the placement of the atom, which should be the central atom, the surrounding atom. So obviously, dito yung central atom is carbon. Carbon is always a central atom. It will always share mangyud its valence electron. So for it to share it sa surrounding atom niya, it should be a central atom. Okay? So we know na siya ang central, yung tatlong oxygen dyan surrounding. And then you total, di ba, the valence electron. That's next step. So you try to total the valence electron, 6 for carbon. No, 4 for carbon, diba? 4 yung carbon na valence electron, then 6 yung kay oxygen. Tatlo man yung oxygen, so ilan ba yan? 18. Okay, so halimbawa, 4, then oxygen, 18. So ilan yan? 22. Diba? 22 electrons. And then this is a polyatomic ion man. It should be reflected din sa kanyang total valence electron yung number of electrons gained. Kasi 2 negative, it means it gains 2 electron. So plus 2. So that's total of 24 electrons. And then after that, you draw single bonds connecting the central to the surrounding, diba, na atom. And then you subtract it. The equivalent electrons na na-distribute natin with these single bond, subtract natin from the total na 24. Per bond, that's equivalent to 2 electrons. Ilan ba yung bonds dyan? Tatlong bonds yung na-present natin. That's equivalent to 6 electrons. Minus 6. Okay, so that's 18 electrons yung remaining. Yung remaining 18 electrons, i-distribute nyo first on the surrounding. Ilan ba yung kulang per oxygen surrounding to attain octet? Kulang sila ng tag-6. Okay? So 246, 246, and then 246. Total of 80. No problem with the surrounding oxygen. They all attain octet state. 8 surrounding electrons. Included na ito. Kasi per bond, 2 electrons na yan. So, octet state na sila. However, in the case of carbon, hindi niya na-attain yung octet. Kaya that's the time, di ba, you change, no? One of the surrounding lone pair into a bonding pair. So, i-change niya yan, okay, into a bonding pair. Na nagkataon nga yung mga surrounding atom dito sa carbon, parehas. Parehas puro oxygen. So, you could either select na A, B, or C, saan dyan na surrounding oxygen, kukuha ka ng isang lone pair gagawing double bond. Okay, or second bond. So that is an indicator nga kung ganitong klaseng case, na pwede pa lang sa another surrounding atom, we could change its lone pair, then form it into a bonding pair. Kung ganun yung case, no, na ma-observe nimo, then resonance is being observed. Nagkakaroon ng electron delocalization in that adjacent atom sa mismong molecule. Okay, so yung ways no to present resonance is presenting all the possible Lewis structure na kaya niyang ma-attain. So tatlo yung Lewis structure nga pwedeng ma-produce for this polyatomic ion. Tatlo kasi pwede naman sa labeled as letter B nga oxygen, kukuha tayo 'di ba ng kumbaga in short, pwedeng diyan mabuo yung double bond or pwedeng between oxygen nga labeled as A towards carbon, pwede diyan din yung double bond. So tatlong klaseng Lewis structure and that means um resonance is being observed. So meron siyang resonance forms. Pero meron itong hybrid. In order for you to kumbaga get the average ng tatlo, you just have to write the hybrid form. So yung hybrid form dito ng carbonate, yung average ng tatlo, paano ba yung average ng tatlo? So kumbaga yung double bond is being drawn in a dashed line. Okay? So halimbawa, ito yung tatlong surrounding oxygen. So visible yung sigma bond. Okay? But yung pangalawang bond, okay, it is in a form of dashed line. That is to show electron delocalization. Okay, electron delocalization. Then, yung nakikita nating charges, di ba, tingnan nyo, yung per structure, di ba may mga charges, may -1 charges. Merong walang charge, 0. That relates to the formal charges in each atom in this molecule. You try to recall also this concept. Dili na kay nato siya i-detailed ha. Basta kay yung mga nakikita nating charges, pwede nyo yung i-relate sa formal charge na concept. Okay? Which tells us na ito yung identifier ng stable binding of atom in a molecule. Of atom in a molecule. Malalaman natin na stable binding ang atom in that molecule kung 0 ang formal charge niya. Wala siyang charge. Meaning stable siya on that state, which is correct, di ba? Sa oxygen, sabi natin, kumbaga, number of bonds for a stable oxygen in a molecule, dalawa lang talaga yung surrounding bond niya. Then yung remaining, lone pairs yun. Dalawang lone pair. Okay, surrounding oxygen. Yan yung stable number of bonds for oxygen. Okay, sige. What else? This is another example ng resonance. Pinaka-common sa organic compounds. Benzene, very popular nga model for resonance. It shows, di ba, conjugated pi bonds, alternating single, double bonds, single, and then double bond. So meron tayong 2 resonance forms for benzene. But usually, paano ba tayo magsulat ng benzene structure? Diba? It's either circle na agad, no, inside the 6 membered nga ring sa benzene, or dashed circle, no, inside its ring. Yan yung hybrid, the average of these 2 resonance forms. Okay? So, yan yung hybrid form ng benzene. So, yan po rin yung reason. Bakit sa lahat ng mga references, always circle radiodiretso ang ginasulat sa middle portion ng ring structure of benzene. That is to show electron delocalization. Electron has been delocalized. Ato sa spell out ha, delocalization. Ayan. Again, yung circle dyan, it shows electron delocalization and that maintains the stability of benzene molecule. Kapag nagkataon may nasira dyan na bond, it's not already benzene. Okay? So, yan. So, resonance din yan. Okay? Sige, next. Let's talk about inductive effects naman. Ito din may kinalaman sa characteristic ng electron. No? Meron tayong dalawang klaseng inductive effects. Depende sa electronegativity characteristic ng atom. Of course, kapag least electronegative ang isang atom, it would tend to donate electron. Remember ang definition nato sa electronegativity? Di ba yung definition natin paulit-ulit na lang, di ba? Yung electronegativity, it is the property, the ability of the atom to attract, to pull electrons patungo saan? Towards itself. Okay, towards itself. So kapag low yung electronegativity ng isang atom, then lower din yung or least din yung property niya to pull electrons. So ano yung gagawin niya? Mas magbibigay siya ng electrons. Okay? It makes sense, diba? Kung least electronegative siya, mas pipilian niya mag-donate. Mas kaya niyang mag-donate. Yan yung isang inductive effect. So it depends on the electronegativity property ng atom. So very common dito, of course, are those least electronegative. Di ba kailan naman ta maka-identify naman ta og highly electronegative atom? Basta highly electronegative atom yun. Ang order yun ana is fluorine followed by oxygen followed by nitrogen. Then pang-apat na siguro yung chlorine. Pero yung top 3 talaga, fluorine muna followed by oxygen, nitrogen. Yan talaga yung pinaka-highly electronegative na atom. So hindi kasali dyan si carbon, lalo na si hydrogen. So kapag hydrocarbons, kapag alkyl groups like methyl, methyl group, more likely they exhibit this inductive effect. They tend to donate electron towards their adjacent carbon atom. So the more electron donation exists, the more stable alpha carbon become. So this is yung nakalagay dito na order is comparing the formation of an alpha carbon. Okay, so it depends on the ability ng mga surrounding yung surrounding ng mga atoms sa alpha carbon. Ito yung alpha carbon, hindi lang siya highlight, yung mismong may positive charge. Okay? Sino dito kumbaga yung easier mag-form ng carbo-cation? Kasi positive charge, so carbo-cation. Okay, so yung pinaka-more stable na forming carbo-cation, forming alpha carbon is yung tertiary. Of course, it has 3 carbons. Mas maraming electrons madodonate. Diba? To these carbon, then kung saan man siya naka-attach, then it would donate even more electrons. So halimbawa, you have here benzene ring. Naalala yung mga concept on different groups that may affect the reactivity of benzene ring, yung mga nagkukos ng ortho-para-directing, meta-directing ng mga groups. We could tell nga ortho-para-directing yan kapag mga electron donating sila. And good example dun yung mga R groups. Yung mga R groups like methyl, they are electron donating. Kasi nga, they have low electronegativity. So, mas pipiliin talaga nilang mag-donate. Okay? Lesser kasi yung ability nila to attract, to pull electron towards itself. So, mas pipiliin nilang i-donate na lang kung ano yung dala-dala nilang electron. So, halimbawa, sa benzene ring. Halimbawa ha, sa benzene ring, merong methyl. Okay? So, obviously, in this given example, since methyl is an electron-donating group, it will donate electrons to benzene, increasing, therefore, reactivity ng benzene ring. Okay? Ayan. So, mas mabilis, kumbaga, yung formation ng or carbo-cation in this case, kasi nga electron donating. Ayan. Okay, so kindly take note of this order. More stable formation of carbo-cation is tertiary. yung sa tertiary, followed by secondary, primary, and least stable yung carbocation formed ni methyl kasi puro hydrogen lang yung surrounding sa kanya. Okay? Kumpara sa tertiary. Okay? Sige. Next, on the other hand, yung another type of inductive effect is electron withdrawing. Ito naman being exhibited by electronegative na mga atoms. Ano ulit yung mga electronegative atoms? Fluorine, oxygen, nitrogen. So kapag present ito, if they exist, added sa isang molecule, then they will withdraw. They will pull. They will attract electrons kasi highly electronegative sila. So that's another inductive effect. So, yun na nga, example, halogens, oxygen. Halogen, fluorine, di ba, is a halogen. Okay. So the more electron withdrawing exists, lesser ngayon yung alpha carbons become. Okay? Lesser ngayon kasi ang tendency, for this given example, more of yung yung relationship dito ng mga electron withdrawing effect towards acidity, yung pinapakita dito. Okay? Lahat ng given example shows the higher priority group na carboxylic acid. Lahat sila may carboxylic acid. Diba? Yung COOH, yan. Yung portion na yan, carboxylic acid. Now, base sa, kumbaga, acidity level nila, going to the right, dito, na set of example, increasing yung acidity. Kasi nga, if you try to compare, on the rightmost part, nga example, mas maraming electron withdrawing nga atoms or electronegative atoms. So talagang, it will pull electrons more towards fluorine. Okay? Kaya greater yung acidity characteristic dito. Pag sinabing acidity, meaning to say, yung property niya to easily release proton. Kasi yun yung definition natin sa acid, di ba? It should easily release proton. Acids are proton donor. Di ba? Yan yung definition natin sa acid. Proton or yung H plus. Easily releases proton or H plus. Yan yung acid. So kung mabilis siyang mag-release, mag-let go ng proton sa kanyang molecule, then it's a strong acid. Okay? Or kumbaga not really strong, but its acidity is increases. Or higher yung acidity property niya. Okay? Higher yung acidity property. So, carboxylic acid man ito, so yung portion niya, na hydroxyl portion, madaling matanggal yung hydrogen dyan. Lalo na kapag may dagdag dito na maraming highly electronegative atom. So that's how these electronegative atom causes enhancement sa acidity characteristic ng molecule dito na example. So ito yung magiging order. So I hope you understand no, bakit etong molecule na to ang mas higher yung acidity compare dito. Kasi nga, kung if you try to count the number of electronegative atoms, mas marami dito. Maraming electronegative atom. In a form of fluorine, 3, 2 oxygen. Okay, kaya madali iyang mag-release ng hydrogen. Madali itong matanggal. Sige. So that's it for inductive effects. So we have electron donating inductive effect, meron din tayong electron withdrawing, and these differs due to differences sa electronegativity ng atom. So that's it for this concept on strain, ayan, resonance, and ito, additional inductive effect. And then finally, yung last topic natin would be isomerism. Okay. Yung isomerism actually is another property din ng carbon atom. So aside pala dun no, sa kanyang property na it is said to be stable, diba? It shows stability. At the same time, it exhibit hybridization characteristic. Hybridization. Sige, recall natin. Pag sinabing stability, stable siya in a way nga, kaya niyang i-share always yung 4 valence electron niya, forming 4 covalent bonds. Yun yung stability. It is said to be stable always. It will never gyud mag-carry og charge, mag-carry og lone electrons. Iya gina pero ni i-share ang iyahang 4 valence electron, forming 4 covalent bonds. Hybridization, yun yung pwede siyang mag-form ng sp, diba? sp2, sp3, hybridized nga carbon. Pag sinabing sp3, puro single bonds. Okay, only single bonds ang present. So, halimbawa, carbon surrounded by 4 na single bonds. So, yan yung sp3 hybridized carbon yan. So, yung shape na tetrahedral. Ito lang i-recall. Then, yung ideal bond angle is 109.5. Okay, 109.5 degrees. Pag sinabing sp2 hybridized ang carbon, then it carries this time one double bond. So it has one double bond. So example, carbon, you have a double bond and the rest are single bond. Okay, so the shape here is trigonal planar. Trigonal planar, and the ideal bond angle dito is 120 degrees. And finally, kapag sp, it could either be meron siyang isang triple bond or dalawa yung double bond. So, sp yan. Okay? Then, what's the shape? Linear. Diba? Linear, and then the ideal nga bond angle is 180 degrees. So, yan yung linear. So, aside from this two, kindly add another property of, ayan, carbon is isomerism. Pag sinabing isomerism, yun yung phenomenon. Phenomenon or yung mismong existence of compound with same formula but different structure. Existence, okay, of a compound with same formula, same ang formula but different ang structure. Ayan. So, yan yung definition ng isomerism. It's a phenomenon. It's all about the existence of sets of compounds na same ang formula but different ang structure. Pag sinabi namang isomers, it is the actual set of molecules. Kung ang dinadescribe niya is yung molecule na talaga, the set of molecules presented na may same formula with different structure, the term that defines it is for isomers. Okay, set of molecules with same formula but different structure. So, among isomers, isomerism, yung differences sa structure, it could either be because of difference in the order of bonding, or it could be the differences in the spatial orientation. Okay? So, pag sinabing differences structure because of the differences in the bonding, okay, differences in the order of bonding, that refers to constitutional isomer. It tells us na different talaga yung connectivity ng mga atoms. May differences sa connectivity ng atoms. That makes them having different structure. Pag sinabi namang ang reason ng differences sa kanilang structure is due to differences in spatial orientation, okay, spatial orientation, and then we're referring to stereoisomer. So this time, we could observe na same lang naman ang connectivity ng mga atoms in the set of molecules. Same ang connectivity. Walang changes sa order of bonding. Nag-differ lang sila sa orientation nila, yung 3D or 2D representation ng atoms, okay, in a molecule. So they differ in the spatial orientation. So that is also considered isomer. Stereoisomer naman yan. Okay, now under constitutional isomer, we have 3 sub-classification. Let's recall them. We have skeletal, or ito din yung tinatawag na structural, or ito din yung chain. Okay, skeletal, structural, or chain. Yung differences in the order of bonding is because of the differences in the degree of branching. Okay, so nagkakaiba sila sa branching. Pag positional or position isomer, differences sa location. Okay, differences sa location of, let's say, the substituent or location ng mismong functional group. Pag functional, as the term suggests, yung actual na talaga na functional group magkaiba for the set of molecules. So those are the 3. And we will be recalling and giving example later under each of the subclassification and constitutional isomer. And then dito naman sa stereoisomer, they could be subclassified into 2. The differences in the spatial orientation may differ in the configuration or may differ in conformation. Under configurational nga, stereoisomer, we have optical isomer, which are usually represented in 3D. 3D arrangement ng atom. So meron silang differences sa ilang 3D representation ng atom. So that's optical isomers. Under this na ay subclassification, enantiomer and diastereomer. So we'll recall them and give example later. For now, just know nga ang enantiomer, okay, enantiomer or enantiomer, this is having mirror images, but they are non-superimposable. Kapag sinabi namang diastereomer, non-mirror images, and at the same time, non-superimposable. Okay, so these are 2 examples na pwedeng classified as optical isomers. And then later, we'll try to recall how do we identify nga ang usa ka molecule is said to be optically active, is said to exhibit optical isomer. So merong criterias. And then, still under configurational stereoisomer, we could observe different configuration sa set of molecules under geometric nga stereoisomerism. So dito naman, common ito occurring among alkene compounds. It occurs commonly among alkene compounds, or pwede din naman may occur in cyclic. Okay, sulat natin in cyclic. Ayan, cyclic compound. It's saving, ayan. Okay, sige, atong i-recall under geometric later, yung configuration, yung dalawang klaseng configuration, yung cis trans, I know you're familiar naman dito, cis trans, ato lang yung i-recall, and tsaka yung easy configuration. Dito naman, yung i-recall natin is yung R-S configuration. R and S configuration. That's under optical isomer. And then, kapag conformational, they differ on, ganun pa rin, they differ on the spatial orientation. Nagkakaroon ng differences sa shapes, conformation ng molecule. Okay? So, as the term suggests, conformation, it tells us na may shapes involved. Okay? So, there is differences in conformation of molecules. Pwedeng conformation ng open chain or ring, cyclic, nga ring structure. Okay, so this is just an overview, kumbaga summary ng isomers, types of isomers, and its subclassifications. Okay, sige, let's start recalling, reviewing on constitutional isomer. Yung difference ulit dito, kapag constitutional, yung order of bonding differs. So, ibig sabihin, kung different na yung connectivity ng atoms in set of molecules, we could tell nga these are different molecule already. Okay, they may have the same formula, and since different na ngayon yung connection, different na gid ni sila nga mga molecules, different compounds are being presented. So we have structural, skeletal isomer or chain isomer. So here, there is a different degree of branching. Usually, common na siya sa mga alkanes because they are capable, diba, of branching. So example, in the given, we have pentane, 2-methylbutane. So magkaiba talaga mismo yung compound. But try to look at the formula. Observe na both contains 5 carbon, both contains 12 hydrogen. Pag binilang mo yung mga imaginary dyan na mga hydrogen, that's equivalent to 12 hydrogen. Or you can make use of the general formula ng alkenes. Di ba? Ang general formula ng alkenes, it's CnH2n, 2n plus 2. So you just have to substitute the number of carbon kasi alam naman natin yung every points in skeletal structure are carbon. So 5 yung carbon, so you substitute. Then ang mga N dyan, it pertains to the number of carbon. So H, so 5 times 2, 10 plus 2, 12. Okay? So you can make use of that para easier yung identification ng number of hydrogen in the alkane na presented in skeletal formula. Okay? And then, look at the differences ng structure nila. They differ in structure because they have different degree of branching. Yung isa, plainly, 5 straight chain nga carbon connection. Ito naman, it's only a 4 carbon straight connection with 1 branch at carbon 2. You have there a 2-methyl sa butane. Pag positional isomer naman, it differs, yung set of molecules differs in structure because of the differences in the position of the functional group. Or, different yung position ng substituent. So, in the given example, different yung dalawang structure because they have different position of OH. Tama? Yung isa nasa carbon 1, this is carbon 1. Whereas on the second, nasaan yung OH? Nasa carbon 2. So obviously, that's position isomer because the two structure differ because they have difference in the position of the functional group. Or pwede din naman, yung positional isomer is observed in mga di-substituted nga benzene. Okay, di-substituted nga benzene ring. Halimbawa, you have 3 sets here of benzene ring na may substituent nga chloro. So, pwedeng ang representation ng dalawang chloro magkatabi or 1 carbon apart or parallel from each other. So, this example of set of molecules shows positional isomer pa rin. Kasi nag-differ yung dalawang structure because of the difference of the position of substituents. Okay, position ng substituent. Ito, position ng functional group. Position ng functional group. Okay, and we have a positional prefix, no, ginagamit to identify names ng benzene ring that is di-substituted. So kapag magkatabi, we use ortho, di ba? Pag one part, no, 1 carbon apart, meta. Pag parallel, para. That's only applicable if di-substituted ang benzene ring. Sa benzene ring, ragid na sila applied. Ang ortho, meta, para. Only sa benzene ring that is di-substituted. Okay, so that's for positional isomer. And last for constitutional isomer, functional isomer. So as the term suggests din, itong klaseng isomerism or isomer, uh, it tells us na may differences sa mismong actual functional group in the set of molecule. Tingnan, yung una, alcohol. Yung pangalawa, it's an ether. Both structures differ because they have different functional group, but they have the same formula. Same ang formula. Both of them have two carbons, anim yung hydrogen, isa ang oxygen. Same formula, different structure. Specifically, nag-differ ang structure because of different functional group. That's functional isomerism. Okay? So somehow, madaling mag-identify ng constitutional isomer. Diba? Constitutional, common siya sa mga alkanes kapag may degree, differences sa degree of branching. Pag position, yung term mismo, isipin nyo, positional isomer, nag-differ sa position ng substituent, position ng functional group. Functional, yung mismong functional group, magkaiba na talaga. Okay? Isa isa alcohol, isa ether, or isa ketone, ang isa aldehyde, so on and so forth. Okay? Are you still there? Can you still follow? Last slide na ito. Last slide na ba to? Parang last slide. Okay? Sige. So, kaya pa? Kaya. No? Sige, let's have the second nga classification ng isomerism. So, we have the configurational isomers. This falls already under stereo. By the way, nasa stereo isomers na tayo. Ano nga ulit yung differences dito? Differ in the spatial orientation. In spatial orientation. Okay? So kapag sinabing configurational isomer as it is defined, stereoisomers with permanent. So permanent you highlight that. Permanent yung spatial differences ng set of molecules. So we have two classification here, yung geometric isomers and mamaya yung optical isomer. So meron tayong kumbaga i-identify mamaya na configuration under geometric, configuration under optical isomers. And you should be familiar on that kasi you will apply this knowledge also sa carbohydrates. Sa carbohydrates, daghan kaayo isomerism na matatakel. Okay? So, geometric isomers, we mentioned nga common ito sa mga kung double bond carbon-to-carbon alkenes. Or, it may also be observed in compounds that are cyclic. Okay. Yung binigay dito na example na configuration observed among alkenes, okay, is yung cis and trans. So, by the way, kapag meron kayong nakitang carbon-to-carbon double bond, this portion ng molecule, enable yan to rotate. It's very rigid. That portion is very rigid. It cannot be rotated. That's why you will observe talaga permanent spatial orientation there. Kaya may mga configuration that we could identify here. Pag sinabing cis and trans, applicable ito sa simple nga mga alkene. Okay? This is applicable nga concept or configuration isomer under geometric in simple alkene. Okay? How do we know nga simple alkene being represented? If you could only see one group of atom attached per double bond carbon, per vinyl carbon. Naalala yung vinyl carbon, yung carbon holding the double bond. Okay? So, specifically, applicable mismo yung pag-identify na or pag-use ng configuration cis and trans if you observe na yung double bond has one identical group. At least, nasa sila one identical group. So yung given dito is dalawa, identical. Both, try to compare. Both of the carbon holding the double bond, tagsa sila na H, napod siya H. Tama? Tagsa sila may H. Also, tagsa sila may chloro. Pero actually, the minimum requirement here is at least na sila isa ka-identical group, usually represented by hydrogen. Okay? So again, this is usually applied kaning cis trans if at least ang carbon with a double bond has one identical group. Usually, hydrogen. And then yung isang group is a different group already. So itong given example, obviously, we can make use of cis-trans na configuration. Okay? So kailan ba natin masasabi na cis kapag same side? Okay? Same side, yung identical group. Then trans kapag opposite side. Okay? So tingnan, i-compare mo lang. Let me change the color ha. Try to compare lang yung mga group of atoms na nasa kaliwa versus group of atoms na nasa kanan. So yung hydrogen, let's say for example, di ba? Identical groups on the same side, nasa bottom part, silang dalawa. So cis yan. Kung opposite na sila, trans yun. Then when to use naman yung easy na configuration. Yung E at saka Z configuration, applicable naman yan if you have already a complex example of alkene, complex in such a way na you cannot use any more cis trans na configuration. You can actually identify it nga kani nga sample dili naman gini siya cis trans kay wala man tay makita nga identical group. Remember ang criteria or requirement kapag cis trans at least naa sila identical group, di ba? Okay? So kung wala na talaga makitang identical group, then that's the time you proceed make use of easy configuration. Example ha, maghatag ta. So you have a double bond carbon, then dito on the right side, nga double bond carbon, meron siyang CH3, then meron siyang halimbawa bromine. Then sa kaliwa, merong chloro, then sa baba hydrogen. So obviously, try to compare each of the double bond carbon. Wala silang identical groups. Okay, wala silang identical groups. So in that example, easy configuration is best used to identify what configuration for this, no, given geometric isomerism. Kapag sinabing E at saka Z configuration, to identify, you have to know priority groups. Again, priority groups are your reference points. Priority groups are, ayan, okay, are reference points dito. Okay, how do we know priority groups? You have to rank based on atomic number. Rank the first atom directly attached to that vinyl carbon. Sino dyan yung may higher nga atomic number? So use the CIP rules. CIP rule stands for can in gold, pre-log. Okay, that's pre-log yan na rules. Na kung saan, yung rule na yan, it actually ranks, okay, substituents based on atomic number. Okay, that's it. Medyo delay yung mga sulat. Ayan. Delay mo reflect ba sa screen yung mga sulat. Ayan. So CIP rules, nirarank natin yung mga substituents based on atomic number to know which is of higher priority. So kung hahatiin mo siya, you have to rank, no, these two. Sino ba dyan yung higher atomic number? Obviously, bromine, higher. And then, dito naman sa kabila, yung higher priority group, si chloro. Mas higher yung atomic number niya ba? Okay? And after that, okay, after identifying the priority groups, then you have to identify the position ng mga priority groups. If same side yung priority groups, nasa taas sila or both nasa baba, then Z configuration yun. So, para mas madali siyang ma-recall, di ba, I have, kumaga share this to you, yung palatandaan para mas madali. By the way, yung Z nga configuration, that comes from the German word zusammen. German word zusammen, ibig sabihin, same side. So, isulat nyo na lang, same side. Then, kapag E, that's German word ha, from German word. E naman, galing yan sa German word na entgegen. Ibig sabihin, opposite. So, isulat nyo, opposite. Okay? Opposite side. Okay? Para you could easily recall lang. Ano lang siya ba? Para, hindi siya mnemonics, pero palatandaan lang siya. Para madali siyang ma-recall. So Z, same side, yung priority group. E, if opposite side, yung priority groups. Okay? So yan yung configuration under geometric isomers. Cis-trans or EZ. Pag nakita nyo, may identical groups yung dalawang vinyl carbon, pwedeng-pwede si cis-trans. Ma'am, pwede din ba gamitin yung EZ? In this case, na pwedeng gamitin si cis-trans? Yes. As long as you can rank. As long as pwede kang mag-rank sa substituent. May mapili kang higher group at saka lower priority group. As long as ma-apply sa CIP, pwede din siya ma-apply. Okay? Sige. Next, optical isomer. Still under configurational isomer. Okay, optical isomer naman, this is being observed among compounds na optically active. How do we know nga optically active ang compounds? Kapag pasok sa criteria. Okay? Ang criteria, to identify if this optically active, dapat meron siyang chiral carbon. I know familiar mo sa term na chiral carbon. Kapag chiral carbon, naka-sp3, hybridized. Ibig sabihin ng sp3, puro single bonds, di ba? Ang surrounding sa carbon atom. 4 na group meron. In fact, dapat yung 4 na single bonds or 4 na surrounding groups are different. All are different groups. Wala dapat identical. So, halimbawa, carbon, tapos merong chloro, may bromo, may CH3, dito may hydrogen. Di ba lahat ng surrounding sa carbon, iba-iba. So, chiral carbon yan. Ito mismo, yung central, chiral. So, that's the time optically active. At the same time, dapat no symmetry element. Okay? Pag sinabing no symmetry, you can best distinguish them by testing its superimposability na characteristic. Dapat non-superimposable. Non-superimposable. Ayan. How do you test non-superimposability? By the way, it's different from having mirror imaging na characteristic. Tingnan yung, ayan. Diyan na given, ayan, illustration, this actually shows mirror images. Example, yung kamay nga natin, di ba, pag hinarap mo together, they are mirror image. Pag sinabing non-superimposability, tingnan. Kung itong nasa gilid, pasensya na, delay, ay nawala. Sorry. For a while ha. Konti na lang talaga. Ito sa i-share. Pasensya na exit. This one, yung kamay na illustration. Ito yung testing if mirror image ba. 'Di ba? Yung kamay natin, right and left, mirror image sila. Kasi nag-align lahat ng parts, lahat ng fingers na magkaparehas. To test superimposability, ipatong nyo yung kamay nyo on top of each other. 'Di ba this time hindi na magka-align yung thumb, yung other parts no ng fingers. Hindi na magka-align. Yan yung testing superimposability. So ito non-superimposable. Okay, so no symmetry element. Okay? Sige, balik tayo sa slides. Okay, going back to this criterias, kapag ganito, ang compound, meron siyang chirality, property, ayan, plus no symmetry element, then it is said to be optically active. Then ano ba yung definition ng being optically active? Having chiral carbon and no symmetry element. It tells us nga capable siya to have an ability to rotate plane polarized light. Again, optically active, it means meron siyang ability, therefore, to rotate plane polarized light. Plane polarized light. It's either to the right or to the left. Okay? So, meron tayong dalawang klase ng rotation. If yung direction is to the right, this tells us na dextro-rotatory. Kumbaga, given using a symbol or usually designated using a symbol, small letter D, or a positive sign. That is dextro-rotatory. Okay? Meaning to the right ha, right. And then kapag to the left naman yung rotation ng plane polarized light, that is designated with small letter L for lever rotatory or a negative sign. Okay? Sulat natin. Then left. Okay? So yeah. Again, itong dextrorotatory, levorotatory, this only describes the direction ng optical rotation. Okay, the optical rotation. If ang plane polarized light has been rotated to the right or to the left. We cannot actually tell by just looking at the structure kung dextro ba siya or levo. We have to test it experimentally. So this is determined experimentally. Sulat natin. Okay. Determined experimentally. Ang gamit dito actually na equipment is yung polarimeter. We actually have sa laboratory pero it's non-functional for display. So experimentally lang siya. Identified if dextro ba siya or levo. By the way ha, do not confuse it with capital D or capital L nga notation. Kapag sa biochemistry, naka-encounter kayo ng capital D, capital L, it's not pertaining to dextro or levorotatory. Ano siya? It refers actually to the position of a hydroxyl sa isang presentation or kumbaga, representation ng isang carbohydrate. Particularly, sa biochemistry naman ni siya good. Pero basin inyo siyang ma-confuse ba sa inyong notes, basin inyo siyang gisulat nga capital D or L, kindly take note na lang. Although naapoy mga references na gaingon nga kung capital D, capital L is also pertaining to dextro or levo, but actually it is not. Okay? Sa biochemistry nga aspect, Okay? Iba din yung ibig sabihin ng capital D at saka L. Referring siya to, isulat ko na lang, to the position of the hydroxyl in the last chiral carbon, of a molecule. Okay? Presented in Fisher projection. Okay? Example, you can actually search this. Try ninyo i-search yung mga halimbawa nga di kaysa biochemistry naman gid ni siya. And I know it will be touch good. I'm confident enough nga matouch gid ni ninyo nga discussion or review kay Sir Mortel. Di manos kana. Try ninyo if you're curious good sa iyang structure. Di galactose. Ayan. Kana siya basta na D nga configuration sa carbohydrate and look for its Fisher projection. Ang Fisher projection ha, not the other 2D or 3D nga mga projection. Kasi lahi-lahi man gid ang ways to present the 3D arrangement ng atoms in a molecule. So sa carbohydrates, usually in a Fisher projection, hanapin niyo yung D-glucose, D-mannose na Fisher projection and then check the OH portion ng kanyang last chiral carbon. If nasa right yung OH, it's D. If nasa left yung OH in the last chiral ha, we're talking about the last chiral carbon, it is an L. Okay, so do not confuse that letters, kani nga mga letters, capital letter D and L nga notation being dextro at saka levo, it's different ni siya ha, nga notation. Sige. Balik tayo sa optical isomerism. Yung given nga example dito, okay, actually represents enantiomer. Okay, yung kay lactic acid. This represents specifically chirality, enantiomer ng lactic acid nga molecule. Kasi pinakita dito positive. Di ba pag sinabing positive, dextro yun. Meaning, it has the ability to rotate plane polarized light to the right. And then kapag negative, levo, to the left. And again, by just looking at it, dili ta makadistinguish nga dextro ba na siya or levo. By looking at the structure, experimentally gini sila gina-determine. Polarimeter, yun yung equipment. Polarimeter, yun yung equipment na nag-identify, determine its configuration. If dextro ba, not the configuration, but its ability ba to rotate plane polarized light. Okay? Sulat natin para hindi kayo ma-confuse. Yung dextro and levo, they describes direction ng optical rotation. Direction of optical. Okay, so it's saving for a while, ha? Okay, optical rotation. Ayan. Sige. So yung given example nga lactic acid, dextro at saka levo, both represents enantiomer. Kasi ang definition natin kanina dito sa, ito ibalik ha, kanya siya. Pag enantiomer, mirror image, non-superimposable. Ayan. Mirror image, non-superimposable. That's under optical isomer. Okay? Sige, balik tayo sa baba. Ayan. Sige. So, try nyo iharap yung, ayan. Sige, medyo delay. Ayan. Iharap nyo yung dalawang lactic acid presented. Diba? These are mirror image. Iharap nyo siya together. Same kanina yung dalawang kamay nung hinarap natin. Nag-align yung each part. Diba? Kung ihaharap natin, mirror image sila with each other. So, mirror image. Pero, kung itetest natin yung superimposability, ipapatong natin yung isang structure on top of another structure ng lactic acid, hindi na ngayon mag-a-align, no, yung mga surrounding atoms. So non-superimposable ito. So it shows enantiomer. And usually kapag enantiomer, set of enantiomers, they only contain one chiral compound. One chiral compound. And we could identify a particular configuration dito, which is the R configuration or an S configuration. Ito mismo yung kayang ma-identify by looking at the structure. Itong klaseng configuration na to on optical isomers. Pero ito yung dextro at saka levo. Dili ni siya ha, experimental gina siya ma-identified. So aside from that, dextro and levo, meron tayong other concept no related to enantiomer and diastereomer, yung configuration that describes arrangement ng atoms around the chiral carbon. Okay? So yung again, yung R, S configuration. Ito naman, ito yung nagde-describe. Okay, it describes the 3D arrangement ng atom. 3D arrangement of atoms around the chiral carbon. Around the chiral carbon. Ayan. Medyo delay yung sulat. Hintayin natin ha. Konti na lang yun. Ayun. So RS configuration, they describes the arrangement ng atom around the chiral carbon. And to identify if it is an R ba or an S configuration, we also use the CIP rules. It applies CIP rules here. Okay? Ano ulit yung CIP? Yung can in gold pre-log rules. Kung CIP can in gold pre-log rules, i-relate nyo agad yung ranking of groups, atomic groups based on atomic number. Basta CIP ha, we are ranking here priority groups based on atomic number. Okay? So kapag ang rotation, not the rotation, but if the arrangement of the atom, okay, surrounding a chiral carbon is clockwise yung arrangement niya based on priority group from highest to lowest, then that's our, okay, configuration. Sige lang, maghatag tag example. If clockwise ha, yung arrangement, we're talking here about the arrangement of atoms. So that's enough. Medyo delay lang siya ma-reflect sa screen. Kay hinay ang net. Ayan. If clockwise arrangement of atoms from highest, okay, priority group, okay, to lowest, okay, priority group. Ayan. Ay, nag-saving pa siya. Okay. Priority group, that is an R configuration, if clockwise. So, on the other hand, if counterclockwise yung arrangement ng atoms from highest to lowest, then that's an S. Okay? Sige. Tingnan natin yung given example. Diba? This is an enantiomer, yung lactic acid kanina. Ayan. Okay? So, no problem yung dextro levo, experimental man na siya, ma-identify. Doon tayo sa mas ma-identified. Kaya natin i-identify by looking at the arrangement ng atom surrounding that chiral carbon. Now, by the way, kapag isa lang yung chiral carbon, enantiomer yung kaya niyang, considered siya as enantiomer. Kung isa ang chiral carbon meron sa molecule. O, isipin natin. Atong i-reorient ha. Sige. Yung mga kulay pink dyan, that's an OH. Based sa katong lactic acid, ayan. Diba color pink ang iyahang representation. So isipin nyo, hydroxyl yan. So ato na lang ibutang. Hydroxyl. And then yung mga kulay green, It represents the carboxyl portion. Yung color blue naman, that represents methyl. Ayan. Again, 'di ba ang naadira sa next nga ayan, sa next nga figure, diagram, puro 1 2 3 4. 1 2 3 4 yung surrounding. That is actually the label based sa color ha, gilabel lang niya. Okay? Para ma-distinguish nato unsa iyahang gina-describe nga atom, group of atoms. So yung color green, it's the carboxyl portion, yung mga color pink dyan, the hydroxyl, color blue, methyl group. So mirror image, non-superimposable, enantiomer sila. Yung purpose natin ngayon is, let's try to identify if R or S configuration. Kasi yun yung kaya na identify by just looking at the 3D arrangement ng atom surrounding this chiral carbon. Okay? So, para madali nyo siyang ma-identify if R or an S, okay, you can make use no of, try na to ha, ato siyang i-reorient. Nga siyang arrangement this time, nga sa baba. You have to use here the CIP rules. I-rank ninyo ang mga atoms directly attached to chiral carbon. Okay? Sige, ato sang i-label again. Kating color pink sa baba. Kanang murag steering wheel na ba? Na representation. It looks like now a steering wheel. Reorient. Oh, ay sa ha. Kay nalobat na si ma'am. Okay, for a while. Atong i-charge. Okay, while waiting for my iPad na mo-turn on, for the attendance purposes, can you please write your name in the chat box for attendance purposes? Kasi last lecture review naman natin tonight. Thank you. Okay, let me resume. Okay, we are now down to the last diagram, no? Yung nasa baba, this is just to, yes, pangaon lang mo, diha, Miss Grazel and the company. Yes, no problem. Na-record ra ba no? Ako lang ni siyang putulon. Na-record ang adlib. Yeah, kaning nasa baba, this is just to analogize it with the structure ng isang steering wheel. Yung nasa sa gilid. Diba, it looks like now, its orientation this time looks like a steering wheel. Tingnan natin paano yung turning. Okay? Ng arrangement of the atoms. Is it clockwise ba ang turning or to the right? Or counterclockwise ba? Para malaman natin if it is an R configuration or S configuration. Sige, isipin niyo ulit ha, lahat ng atong i-label sa, na-erase, hindi siya na-save, manggod. Okay, for a while. I think lobat din ang ako ang ano, hindi na din kinaya no ng iPad nako og ako ang pencil. iPad na lang ang ga-charge 2%. Ah, napa 58% si pencil. Sige, wait sa. Kamo, okay pa ba ta? Okay pa ba mo? May I know sa chat box kung okay pa ba ang lahat? Gamay na lang yun, no? Para kasalang yun, kadali lang. Okay, para relax na mo by Wednesday, ready na mo sa gera on whole day review. Whole day, yun siya, di lang 2 hours, 3 hours. Kaya niya yan. Whole day on 14, 15, and 16. Oh, okay. Okay. Sige, go. Kaya mo yan, Nathaniel. Okay, yung mga color pink, isipin natin OH yan. Base sa katong lactic acid. Okay, lactic acid nga structure. Okay, OH, and then ang color green again, yung carboxyl portion, COOH. Ayan, carboxyl. And then yung blue, CH3. Ayaw na nato i-rank. Di na nato i-rank ng 4 kay hydrogen man na siya. Okay, ganun 4. Based sa lactic acid nga presentation. No need to rank hydrogen. Least good siya or low priority group gid ang hydrogen. Okay? Sige. So, paano ulit mag-ranking dito para ma-identify if R? To determine no R or S, we need to apply the CIP rules. The Can and Gold pre-log. Ang Can and Gold pre-log, ira-rank natin ang mga atoms based on atomic number. So, yung mismong atom ha, directly attached to the chiral carbon. So, here, it's the carbon. Here also, another carbon. O, tingnan. For on the left side, okay, on the right side, we could tell na ang rank 1 would be yung OH. Okay? As being labeled, siya daw yung 1. Okay? Kasi nga, yung oxygen is higher yung atomic number niya kumpara sa carbon. Again, yung una niyong i-rank is yung una talaga, yung first element directly attached sa chiral carbon. First element directly attached ha to the chiral carbon. Kung nagkataon na parehas, carbon dito, carbon din sa, halimbawa sa number 2 at saka 3. Diba? Carbon yung first element attached. Proceed to the second element. Okay? On that group of atom. So dito, this is said to be ranked as the second priority group, si carboxyl, kasi next to it is oxygen. Okay, next to it pa si oxygen. Kumpara dito, si oxygen directly, no, ang naka-attach kay chiral carbon, kaya siya yung higher priority. Then lastly, syempre itong CH3. Kasi hydrogen lang puro, no? Puro hydrogen yung next to carbon. Okay, yung CIP rules again ha, know the atomic number. Sino yung mayroong higher atomic number? That's the time you could rank them. Sino yung una, pangalawa, and pangatlo. So, in-arrange lang ito based sa priority groups, applying CIP rules and analogizing it just like a steering wheel. Okay? So, tingnan, yung arrangement ng priority groups is going to the right, di ba? Hala, nawala na gyud. Hindi na talaga niya kaya gyud. Nalobat na siya. Sa kaya ba nga sa Wednesday mag-quiz na tayo ng mga 40 items? What do you think? Ay, dili na lang di ay. Sige. No thanks. Agoy. Sige. Okay, sige, dili gid kaya no. So mag-review na lang gid mo. Sige, then mag-prepare gid mo ha, mag-relax gid mo sa kuan. Dili ba sa yun ang whole day gid, 8 hours mag-lecture, ay may maminaw og review lecture. Kapoy na gani ang 2 hours. Murag nag 2 hours naman yata ta or 3 hours. Muampak lang. Okay. So you prepare yourself sa inyong incoming a 3 day whole day nga review lecture, and it's biochem gud siya no o kuan. Pero hindi lang siya nalagay sa schedule na gi-post ni Dean para dili mo ma-confuse man ato. Kay lagi ako daw ang sa first part ng organic chemistry, but Sir Mortel, na I believe mo po nahitabo ilaha katong na mga previous batch nga under gapon kay Sir Mortel nga naka-join gihapon karon sa seminar 1, niagi na sila kay Sir Mortel. So nana sila yung notes kay Sir Mortel, and before gid siya mag biochemistry nga review lecture, ga org chem na siya mga 1 hour or 30 minutes iyang gina-review ang org chem. Sige. Mag-compre, yes, mag-compre. Sem 1 akong nabalaan. Dili ko sure sa Sem 2 kung mag-compre. Sige, atong ikuan ha. Ni-on na ako ko. Gamay na lang gid siya. Nalobat lang gid ato ang. Sige. So, dili lang ta mag-quiz. Magpahulay lang mo para ready mo on November 14. Pagkaon lang mo ha kung gigutom na mo. Sa ako nga part, wag gyud kaon-kaon the whole day. Gaga-diet gid ko. Kay nagtambok na gid kay ko. Nag-ano lang ko, kanang mga little lang nga mga snack. Na lang ko'y alternative. Karon nga di, wala gid ko nakakaon. Sige. Basta ka mukaon gid mo basta mag-review. Importante gid kaayo nga source of oxygen, source of sugar ang inyong brain cells. Saon man pag-function sa inyong brain cells mo sulod inyong walay oxygen nga mo ma-distribute sa inyong brain, no? Kaon gyud mo taman-taman. Sige ato next. Okay. Saba kayo ako hero no. Pani ako. Sorry kaayo gyud. Ako nang hero na saba. Sige. Okay. Start na ta. Ato ikuan ha. Sige, atong balik tong nakasulat na label. Ranked as priority group, highest priority group yung OH, followed by the carboxyl, and then the methyl. Hydroxyl, and then ayan, carboxyl, methyl. Okay, so try to observe the turning. Okay, the arrangement of the atoms based on CIP rules. Our configuration nito kasi going clockwise. Going clockwise, going to the right. Tama? Yung arrangement ba ng priority groups from highest to lowest. Whereas, yung S configuration is yung nasa right side. Saba, gid ako ang iro, no, pasensya, gid kaayo. Sige, so ayan. Yung S configuration naman is going counter to the left. No? Left turn, counter yun. Counter clockwise. Okay na? So somehow, madali lang siyang i-identify. As long as you can rank it. No? Rank it based on atomic number. So dapat alam nyo mismo yung kumbaga mayroon kayong photographic memory sino yung mga nasa bottom portion ng periodic table kasi yung mga nasa bottom part, it automatic sila yung may higher atomic number. Diba? Or yung mga nasa rightmost part and going down ng periodic table, sila yung may higher atomic number. So, higher rank sila based on CIP rules. Ito naman clockwise. So, please know the difference between RS, kailan ba siya ginagamit, kailan naman yung dextro at saka levo. Dextro levo rotatory, it describes lang yun the direction of optical rotation. It is determined experimentally. Ito naman, we can identify this by looking at the 3D arrangement of the atoms around the chiral carbon. So, ito yung kayang ma-identify by looking at the structure, R or S. R, rectus. Galing yan sa rectus nga term. S, sinister. Rectus means right. Sinister means left. Okay, and then yung diastereomers naman, hindi lang nagbigay dito ng example, no? Basta please know nga, more than one chiral carbon. Okay? Sige, maghatag tag example. Okay, mas ganahan man mag-example. Let's have yung tartaric acid. Okay, yung Fisher projection ng tartaric acid. Kanina, lactic acid yun. Okay, let's say, eto. Naka 2D lang ito, no? Itong given na example tells us na meron siyang dalawang chiral carbon. Okay, ito yung mga chiral carbon. Isa, then dalawa. So this is an example nga kumbaga molecule na pwedeng makabuo ng diastereomer. Okay, diastereomer, more than one kasi yung chiral carbon meron siya. Okay? However, the rotation, not opposite about all chiral carbons. Okay? Kumbaga, ang ibig sabihin yan is, hindi automatic. Di ba kanina sa enantiomer, kung ang isa identified as R, automatic, yung isa is an S configuration. Meron dapat siyang equivalent nga S configuration. Okay, whereas kapag diastereomer, it tells us na hindi na automatic lahat ng chiral carbon. Or hindi lahat ng rotation ng chiral carbon, okay, opposite. Kung let's say for example kani S yung configuration. Okay, S and S configuration din yung isang chiral carbon. Hindi automatic na yung isang equivalent niya nga stereoisomer forming diastereomer R yung configuration nito. Okay, hindi automatic. Pwedeng isa lang, at least isang chiral carbon, dun sila nag-differ ng kumbaga configuration. Halimbawa, pwedeng sa una, okay, yung una is an R pero yung isa still same sila, S configuration. Pwedeng sa isang chiral carbon lang sila mag-differ ng rotation. Yan yung ibig sabihin dito na statement. Not opposite in rotation about all chiral carbon. At least, they differ on rotation sa at least one chiral carbon. Okay? So, yan lang po yung diastereomer versus enantiomer. Both, again, exhibits optical isomers. Okay? But the pinaka-common talaga na optically active na set of molecules, enantiomers. Kaya nga, may mga references. Kung i-search ang optical isomers, it is also known as enantiomers or enantiomers. Okay, siya yung common na set of molecules that observable talaga ang optical isomers. Then sige, last, ito pinakamadali din talaga yung conformational isomer. It's a set of stereoisomers of the same compound. Tingnan ha, same compound but with temporary differences. So what we are presenting here nga set of molecules, set of structures are the same compound. Nag-differ lang sila sa structure in terms of the different conformations, different shapes. Okay? Sige, so example, conformations around rotating bonds presented using Newman projection. Kanina, di ba na-present na ako, itong klaseng presentation ng ethane. Okay? This is actually ethane, yung CH3, CH3. Nalala yun? Yung dalawa carbon, anim hydrogen. Ito yung tinatawag, di ba natin, na staggered. Nalala, yung staggered conformation ng ethane using Newman projection. Na kung saan this time alternating na yung alignment ng hydrogen na nasa fronting carbon at saka versus yung mga hydrogen na nasa likod na carbon. Ito naman yung eclipsed. Eclipse kapag may alignment, okay, ng surrounding atoms. Okay, may alignment, may parallel bonds, kumbaga. And anong klaseng strain ulit yon kapag observable sa mga eclipsed nga conformation? Anong strain yon? Is it a ring strain, torsional strain, steric effect? Okay, it's torsional strain, ha? Kapag may alignment parallel bonds. Okay, between the two, more stable. You know this already. Ang staggered formation is more stable. Yung eclipsed formation is less stable kasi nga may tendency na magkaroon ng torsional strain. Kaya less stable yung eclipsed. Okay? So, Newman projection, yan yung one way to represent 3D. Naka 3D this time, no? Yung arrangement ng atoms in molecule. Yung Fisher projection, obviously, this is just 2D. 2D presentation na siya. Ginagamit usually ang Fisher projection in presenting carbohydrates. Mga structures, molecules ng carbohydrates. Then, last na. Okay, cyclohexane. This is also another example. No? Kanina ito open chain. Pwede din naman, ang conformational isomer is observed in cyclic ring. Cyclic ring by just folding, if there is folding of the ring. Example sa cyclohexane, binigay ko na ito na example, diba? Meron siyang dalawang existing conformation, the boat and the chair, which is more stable again. Okay, it's actually presented naman, no? It's the chair. Chair is more stable kasi nga lesser yung steric effect. Kung naka-boat conformation, ito yung highlighted halimbawa na hydrogen, magkalapit sila. So there's a tendency na mag-compete sila ng space on that area causing steric effect. Okay? So more stable ang chair. Okay? Na it looks really like a chair. Kaya tawag sa kanya chair conformation. Okay, then you try to recall also nato sa atong mga notes, hindi lang nakasulat dito, yung mga conformation for cyclopentane. Okay, cyclopentane na ring structure, yung envelope. Okay, then yung cyclobutane. Cyclobutane, yung butterfly. Okay, so that's it. Okay, so overall, we are done, no? With isomerism, no concept. Medyo mahaba yung isomerism, no? Pero ang concept lang yun dito is more on kanang pointing out na there are set of molecules na may the same formula but they differ in structure. Pwedeng yung difference in structure is because of the differences in the order of bonding or yung differences in structure is because of differences in the spatial orientation. Okay? Sige. So that's it for the first part ng organic chemistry review. So the rest, I will just hand it over na kay Sir Mortel. He will continue na. The rest, 3 pages na lang yan. Pero medyo mas madugo actually yung sa reactions. But I know I am confident enough kasi you have accomplishment past, diba? Organic chemistry, medicinal organic chemistry, biochemistry. So kani sort of review lang yun ang mahitabo. Naana mo'y prior knowledge, ato lang yun siyang iligon for retention purposes, for review purposes, para 100% na sadta sa board exam, no? Ang purpose naman yun nato is ma-attain ng 3 letters nga atong gusto ma-attain, the RPH. So, let's aim for that. And I know, kaya na ninyo. Kaya na nila? How much more kaya pa na ninyo? Sige. So, that would be all, no, for our first part ng review ng OrgChem lecture. Do you have any question? Question sa... Kung wala question, I know na question na po mo PM na yung mga ano na yung mga confusion or clarification. Yes, Mr. Sabio, go clarify. Yes, you're raising your hand.
Yes, ma'am. Regarding po sa scheduled na quizzes po,
Yes.
asa po ato ang i-follow katong gihatag ni din sa amo ganina or
Kung
katong
sa ganito
imuhang
yung
gihatag?
schedule, sige daw, i-mention daw.
Iyahang gihatag sa amo ma'am is 2 quizzes only for OrgChem, which will be on the next Wednesdays po, 20 and 27. And gibakante niya ang 23, which is Saturday, nga supposedly dito ato ang second quiz. And then ang ato ang semifinals exam will be on December 4 na ma'am.
Ang 23, wala 23? No, November
Wala ma'am, gibakante ni Doc ma'am.
23. Yes, sakto di ay kay proposal defense na ano na nako. Nalimtan na nako akong research. Naman day research third year. Proposal defense nila 21, 22 and saka 23. Sakto. So November 20 ambak ta sa November 27. But expect nga ano siya, yung same nga instruction sa akong gi-provide. Kay gusto man gid ko mahuman mog dali sa assessment para naamoy taas nga time. Na ako'y gusto ibakante from her schedule nga gi-provide para naamoy time to prepare for biochem for finals ba nga assessment. Okay? So yes, tama nga duha ra ka days. Duha ra man gyapon ni ka days ang akong giset sa initial 20 and 23. So mahitabo instead of 20 and 23, mahimo siya 20 and 27 ni siya, November 27. So naay bakante kano sa ang semifinals gi-schedule ni Dean?
Kuan ma'am, December 4 ma'am.
Meaning bakante na mo ana. Okay ba ta? Para namoy time nga ma-ready mo or kamo okay raman sa ako kana nga schedule pero ang akong purpose is para taas din inyong time sa next for finals ba nga preparation. Di ko ganan nga sunod gyud diretso inyong mga assessment every Wednesday and Saturday, Wednesday and Saturday. Kayo, you can decide also. Let me know lang if naay mag-message nga, ma'am, according sa majority gusto mi atong schedule ni Dean, then it's fine with me. Okay? Pero kung eto, okay kayo ani nga scheduling, nga na ay musugot ra mo nga 2 quizzes lang ang assessment for semi comparing to 3 quizzes set with lower items siya, 50, 50, and 40. That's for the 3 sets of quizzes. Okay? And then 60 items only ang exam. Then you can follow this. Okay? Pero kung naay gusto mo, ang majority nga I will also be okay, fine with me gid na. Okay ra sa ako ang schedule. O may I ask na lang the majority. Karon, may I ask the initial response na lang sa majority. Can you raise your hand if you wanted the schedule ni Dr. Aquino? Kasi I will really change the total items if different. It would be the first quiz is 100 items and then the second quiz is also 100 items. And separate man ang days sa exam, so it's also another 100 items for exam. So 300 tanan. So it's okay with me. Sige, go. Who wants the schedule of Dr. Aquino? Katong November 20, first quiz, November 27, second quiz, and no more third quiz. December 4 is semifinal exam. Sige na, go. It's okay with me kung okay mo sa schedule ni Dean. Okay, so si Ray. Okay, si Ray. Unsa man ni? Meaning nag-agree si Ray sa schedule ni Doc. Okay? Sige, how about the schedule nga taman rata 27, November 20 and 27 for semifinals nga assessment schedule. Wala pod. So, wala po may ganun. So, asa natin ka mag-quiz ani? Sige. Okay. Sige. How about the others? I-kick out na lang nako ning others kay wala man sila tubag. Sige. What if dili na lang mag-quiz, no? Correct. Kada na siya nga kuan. So blank ang atong zero to tanan sa semi kay wala scoring. Okay, sige. Kung moabot siya 40 people for this assessment, then we'll find makanigid siya. Napa-Japan plus point. Wala na yung plus point, siguro wala na yung intrams. Oh, wala na yung intrams lang ga. May 50, 50 na. 46. Mag-intrams na balik. Oh, pwede rasad. Mag-intrams tag-atua lang. Pero pwede manaygon. I am sure nga dili na ninyo need ang point sa org-chem. I feel like nga mas hiyang mo sa org-chem. I'm sure nga hiyang mo sa org-chem. Kaya more analysis siya. Dili siya memorization pareha sa in-org. Ahami, maka. So, ato nang i-close. So, since majority, syempre, majority wins man yun ang ato ang ruling democratic man gyud ta. So, atong i-finalize kanina ang atong assessment schedule. Let's respect na lang the majority. Okay? So November 20, first assessment. Yes, 100 items siya, but ako siyang hation. Ang 50 items, it's a separate pointers. So kabalo mo unsay mo gawas. Then sa second quiz, another 50 is separate po siya nga pointers. So November 27, it's still another 100 per nahati na siya. Ang 40 is recorded as third quiz. And then the remaining 60 items is for your exam. Sige, I'll try my best nga kanang mga basic questions naman this time. Okay? Although namang po'y sagol nga mga complex para lang gid ma-assess kung kaya din ba yung mga pero for kanang kay murag complex gid kay to akong gihatag sa in-org, no? Gituyo gid nako sa in-org. Kay nakita man gud nako nga akong mga previews nga mga questionnaire kay it is still been utilized also, no, by other students. So para lang na ay something new sa uban nga mga items ato na koy na complexity added. Okay, so ato yung finalize ha, kanina siya. Nga schedule para November 28, 29, 30, preparation na mo ana the whole isang week good preparation for your next sa inyong final term na dayon nga assessment. So enough gid kay na nga preparation ha sa inyong final term naman. Okay? Unsa tong mga question ay mga question. May makahangyo na dili madungan ang quizzes kay Ma'am Louise. Muduo lang mo kay Ma'am Louise. Miss Lim. Lim na atong i-address no kay Cheska. Mas hiyang mi og na ay kana lang yun no. So sige lang, dili lagi na ninyo need na ang plus points kay kaya ra lagi ang org-chem. I'm sure. Kaya ano na to. Atong bawion ang midterm. Okay. I'll help you this time sa midterm. Bantay lang yun ha, dili ma-perfect. Okay, Christmas man po. Basta mag-study lang gyud. Study the concept and I'll try to assess gyud every item nga sounds like basic gyud siya nga mga question. Okay? So maghatag ra ko og recording. It could be tonight or tomorrow night and including the pointers. Okay? Sige, pointers sa quiz 1, quiz 2, quiz 3, including sa final exam. The semi-final exam. Sige. So kung wala na ilain question, I will now dismiss the class. Okay, thank you everyone. And God bless. Good luck sa inyo ha. See you next week. Bye-bye.
Thank you, ma'am. Goodbye.
Sige, bye-bye.
Bye, ma'am. Thank you.
Sige, bye-bye everyone. God bless.
Thank you, ma'am.
Bye-bye.
Thank you, ma'am.
Sige, sige.